Good morning, everyone. Welcome to our 5th webinar on steel wire rope from the Lifting Solutions Group. Today, we're going to talk about end terminations and cutting ropes with my colleague Ellen Bouwman from Vebinārs, Belgium. Before we talked about the basics of steel wire rope, special cable, lubrication and inspection, visual and MRT. But today we're going to talk about end terminations and cutting ropes. My name is Michel de Vos. I'm marketing manager from the Vebinārs Group, and I will be your guide to the webinar. Please remind me that you're on mute, and if you have any questions during the webinar, please type them in the chat. And after Ellen, his story, we'll have some time to do a Q&A, and he will answer most of your questions. And if not all questions are answered, we will send them afterwards. We will also send afterwards this presentation and the recording of this webinar. First of all, let me see, I need this one. A short introduction about our company. We're part of Axel Johnson International, which is a privately owned industrial group that acquires and develops companies in several strategic niche markets. And the Lifting Solutions Group is one of those 6 business lines within Axel Johnson International. So we're in Lifting Solutions Group. It's working. Yeah. What do? We're a global player specialized in lifting equipment, steel wire rope, and services, but also fall protection, operating as a group. 22 companies in the group within 19 countries, and every country has almost its own local company that serves local customers. Here you see a little footprint of our company within the world. Mostly is situated in Europe and Scandinavia, but since a couple of years we have Australia with 5 companies, and we also have the part in the USA since I think it's last year. So we're pretty much spread it into the world. This is our group within Lifting Solutions Group. As said, a group of companies with strong local brands and presence and serving customers worldwide. And I think one of those logos looks familiar for you. One of those, yeah. Last slide for this introduction, then I'll hand over to Alain. This is our promise to the customers. We don't only sell products, we sell expertise, safety, quality, service. That's our main goal in everything we do, which is named the Lifting Know-how. For now, the short introduction. Last slide, of course. Subjects already know, end terminations, cutting ropes, and now hand over to Ellen. Enjoy.
Well, very good morning from me to everybody who's listening and viewing. Good morning, good morning. My name is Alain Bouwman. I'm an industrial engineer, and for the last 36 years I've been, let's say, working, advising, investigating ropes at Vebinārs, Belgium. We do service life reports. We have a little laboratory to investigate ropes which come back from customers. We climb into cranes. We go to the customers and advise them to have longer lifetimes, to go to specialized ropes for their applications and so on. Yeah. So if you need advice, just give us a call. You put it on mail, and we do our best to give you also our advices. Okay, what we're going to do today is talking about end terminations on steel wire rope. As Michel already said, the first seminars were about standard ropes, about high performance ropes, about discarding ropes. Then we had a seminar about greasing and re-greasing ropes. Okay, let's talk today in 20 or 25 minutes about end terminations, because if you've got a good rope, it's very important to also have a good end termination on your rope. Yeah, and here you see some examples. You see some eyes, some timbals, some sockets. Okay, let's talk about these things which have their certain applications and reasons why, and the advantages and disadvantages. Okay. One of the most common end terminations on ropes is the switched ferrule. Let's say Telluride is a common brand in that. That's a mechanical splice. It is you make a loop or you put a thimble in your rope, and you gonna press the ferrule on your rope. So you do it with a certain number of ferrule, and that has to be done with certain dies on your machine or your equipment, and then you have a lasting eye or a lasting thimble in it. You see the table on the right. This is, let's say, very important to check which kind of rope you're gonna press, or you're gonna switch a thimble or an eye on it. That depends on the fill factor. So the fill factor will give you the right number of ferrule to use and dies. In general, if you have a rope with a fiber core, you're going to need the same number as your diameter. Yeah. If you have a rope with steel core, you're going to add one number up to the diameter. Yeah. And if you have a special rope, let's say compacted, you need to have 2 numbers up for taking the right ferrule. Check it out, because it's very important. Each rope has his specific ferrule and dies to use. It is an aluminium ferrule. That means you can use the rope or the end termination till 110 degrees Celsius. So be careful, but normally it is generally common. It's easy and it's cheap to manufacture, so this will do the job. The efficiency for your rope will be 90%. That means that doing the ferrule swaging will give you a loss of about 10% of your minimum breaking load. Huh? As you can see down there, you have standard ferrules, but also you have conical ones. So, which is, let's say, also with a conical with a little eye in it. So then you can see that the rope is fully through the ferrule. And where I put the arrow, you can see that normally to inspect that the ferrule and the rope are well swaged, you need to see a little end of the rope coming out, showing out of the ferrule, so that everybody is sure that the 2 sides of the rope is completely swaged. Yeah. The second type of swaging is what we call the Flemish eye or super loop. Flemish eye, well, I'm from Flanders, and I can't explain why everybody in the world calls it a Flemish eye. Is it a Flemish invention? I don't know, but even in Russia, even in French, even in all the different languages, it is called a Flemish eye. And you can do it on 6 and 8 strand ropes. What the procedure is, you split your rope, so in 2 parts. We're going to see a movie afterwards, so I explain it first, and then you're going to see the movie. It is spliced by hand into a loop, or you put a thimble in it, and then if you got the loop, then you're gonna swage it with a steel ferrule, yeah, a conical one. And then you have, let's say, the complete splice and swaging, and it had the advantage that you could go up to 150 degrees Celsius because it's a steel ferrule, and even to 300 degrees Celsius, you're going to lose about 25% of your minimum breaking load. But anyhow, so for high temperature applications, this is the one, let's say, to use. The efficiency is also 90%, so you're going to lose, let's say, about 10% of the minimum breaking load. Yeah. So let's see now how things are manufactured. I think we're going to start the movie now. Yeah. First, you just put a line on it where the ferrule will come, and then look at it. The guy is going to split the rope into 2 parts. So this is a 6-strand rope, I think. Yeah. So you see, he takes 3 strands, and he leaves the rope core and the other 3 strands. Then he puts a clamp on it, and then he's going to make a loop. You see, there's a special procedure. You have to know if you're working with 6-strand or 8-strand ropes, if it is with steel core or if it is with fiber core. There's all a certain procedure for it. It is, let's say, know-how, how you do it. You see, he splices the 3 strands back into the loop. This is a small diameter, but you can imagine if you were talking about, I don't know, 58 millimeter, then you're going to need 2 guys to do this job. Yeah. So each strand goes back into position. Yeah. Okay. And the last one. Yeah. So you got an eye. Now we can put a thimble in it if you want. Yeah. But he's going to splice now these little ends into the rope, and then, yeah, you're going to pull the steel ferrule over the splice. Yeah. So this is sometimes a harsh situation. I mean, sometimes you need to have some equipment to really slide it over. Okay, this is the first step. If you leave it like this hand splice will give you about 75% of the minimum breaking load. So in some emergency cases, you could use a Flemish eye, just splice it like this, and then you end up with 75% of the minimum breaking load. Yeah. Now we're gonna finish it up with the swaging. Let's hope it starts. Yeah, okay. So then you need to put your dices, special dices, into the machine. And then for some diameters you use once. For other diameters you use 2 times your swaging dice. Okay, you can see he turns it, and yeah, till the dice are completely closed. Yeah, and then he puts it into another die, let's say. Okay. So he turns it and he waits till the 2 dice get completely closed. Yeah, okay, that's it, guys. So you have your complete Flemish eye super loop swaged and termination. There you go. You see, it is conical, so sometimes it has the advantage that it can be easily used underneath your loads to pick it up. Okay. Yep. Okay, another termination is the swaged forged terminal. You're gonna have different kinds of, let's say, types. You see here some with an eye or some with a fork, or there are some applications where you need a thread end. Yeah, it is all done as seen with special dies to switch on. Yeah. Sometimes there are some standard dimensions you're going to need to put into the dies, or sometimes you're going to end up with custom made things. So be careful, not everybody has all the dies, let's say, in the workshop. So sometimes you need to go to some standard dimension. It is, of course, expensive because these things, have to be made properly. And all the different kinds of dies, they also cost a lot of money. Efficiency is 90%. And okay, so it is, let's say, very special with these kind of forged terminals. Even for end stops, you can use the same procedure. You're gonna switch that end stop also on the rope with special dies. Yeah. Sometimes you have very special end stops with dimensions for leap hair, demak, fotodano. These dimensions, they depends on the socket you're going to use on your crane. These end stops switched are normally done on new rope. Yeah. So the diameter of a new rope will fit into these end stops. And attention, if you're going to use it due to damages you're going to have on used ropes, then be careful. Normally we do a test then to see if the fitting is 100% safe. So you have in the pictures different types of end stops, round ones, special ones, though be careful. These dimensions have to be checked. Yeah. Another very common end termination are sockets. Sockets like you see here, so open spelter socket or closed ones with certain pins or with bolts and so on. So this kind of socket is the strongest end termination and it is reusable. So if you're going to use it with a spelter socket with a wire lock, with resin poured on, normally you can empty the socket afterwards and you can use it again. So sockets are reusable. This gives you a price advantage. How is it done? Well, this is the only end termination which give you 100% of the breaking load of your rope. And it is, of course, with a certain procedure done. I give you a little show here how this thing has to be done. First of all, you have to size your wire, yeah, like it is there in the pictures. So you need to seal your rope. Then you open up all the different strands, yeah, even the center core. If it is a rope core in it, you have to cut the rope core out of it, yeah? And then you open up all the strands to form a broom. Yeah? This broom has afterwards it's necessary to degrease it, because you have in your rope, normally you have a certain amount of grease, but for socketing, the broom has to be 100% clean. So we have to do some degreasing on this part of your rope, yeah? Then you pull the socket over it, and then you make your two-compound resin. Normally it is a powder and a fluid, which has to be mixed thoroughly. And then, okay, you pour it into the socket, and then you wait about, let's say, half an hour or an hour, depending on the temperature or the greatness. I mean, the dimensions of the socket. Yeah, you wait for, let's say, 1 hour, and then you can use your socket and your rope immediately. This was the first resin which was certified by Lloyd's. So it is still the original one, let's say, invented in England. You can use these end terminations till 150 degrees Celsius. Be careful, there are other resin types which are not usable till 150 degrees, yeah, only till 70 or 80 degrees, and be careful if you use these things on, let's say, a dredging ship. Yeah, if these sockets are into the sun, let's say in the Pacific or something, these can get easily up to 100 degrees in tropical situations, so be careful, yeah. And I have to mention also that this wire lock is coming into sets. You have the fluid and you have the powder to mix. There is an expiration date on your sets, so be careful that you use the right ones. This is socketing. Let's see how this works in practice. We have a little movie. I'll show you. If you've seen it once, you're going to remember it forever, I think. Oh, something's gone wrong. Just turning back. I think, yeah, okay. There it comes. Yeah. Sorry, guys, but yeah, this is technique. Okay, let's do it. So, first of all, you have to have the right dimensions, where the socket is coming, which part of the rope is to be needed to open, and then you have to seize it thoroughly. Look at this. This is well done, I think. It's a Manus invention, I think. Okay, you see. Yeah, very well seized. And then you open up all the strands. I think this is an 8-strand rope. So every strand has to be opened up like this. Again, if you have a steel core, you open up the steel core too. If you have a fiber core in it, you cut the fiber core. Yeah, cut it out. If you have a high performance rope with plastic infill, you have to cut the plastic infill too. So all the strands now have to be opened like this. You see some specific tools we have also invented, yeah, to open up this easily. All the different wires have to be spread into a very nice broom. Yeah, open up thoroughly. You see that all these wires still have a little grease on it. Yeah, you make a very nice broom, and then you go degreasing the broom. Yeah, you have several kinds of degreasers to use. And once you see here, the wires are degreased, yeah, they are clean, let's say, and then you put the socket around it, yeah. Okay, and then you seal the bottom of the socket because you're going to pour fluid into the socket. So you need to seal off the bottom of your socket that it won't drip out, let's say, you see. So this is a special tape we're going to put in there. Yeah, okay, and then we put it into the stand. In our workshop, we have different stands like this. So when we do the pouring, we can pour several sockets at a time. There you got it. And then, okay, we prepare the resin. You have a fluid part and you mix it up with the powder. Yeah, and once it's fully mixed, you can immediately start pouring it into the sockets. You see, you put some in first, so things will get deeper and deeper into the socket, and then you pour some more. So then in the end, you're going to see that this is to the right level. You see, it's gonna going down, down, down. So you wait, and then you put some more in it, and then this is the end situation. And then you wait for about let's say an hour, yeah. And the socket and the resin will warm up till about 50, 60, or 70 degrees. So there is a chemical reaction, yeah. What you can see here is then the end sockets. We normally put a mark plate in it with who's done it, where it is done, with a number, so that things can be checked afterwards. We also re-grease the little part under the socket, which was eventually also degreased. So we put a special grease also under the sockets, so that the socket and the part under the socket is re-greased again. So this is, let's say, the resin type of pouring on. Yeah. In some countries, and especially in Germany, there are still sockets poured on with fluid metal alloy, or let's say Zamak. It is hot metal, which has to be poured in at about 340 degrees. The sockets are reusable, but be careful. Every time you're gonna socket it on with hot metal, you have high temperatures, and sometimes, you gonna heat it up above 340 degrees, and then you have a changement of your socket material. Yeah. Of course, you have also deterioration of the wires by temperatures with this kind of casting. Yeah. You have also 100% efficiency, and the same procedure about the wire lock reason is done, but of course it's much difficult to do it because you have to take care of high temperatures, warming up the sockets and so on. You have the advantage that if you need to use the socket again, then you can let drip out the hot metal of the socket. If you do it with wire lock resin, you have to press the complete conus out of the socket. So there you're going to need a press or something to empty the socket. That's it with sockets. I show you here some more different kind of sockets, like pair sockets, which are very common in bands. And sometimes you have here on the right side, typically sockets from Daymak or from other brands. You can use them. Due to the easy procedure of socketing, the last 15 years, we invented, let's say, end stops for socketing on ropes. This is done with, let's say, smaller pieces of end stops, as you can see, with special houses or with special sockets where this end stop will fit in. Yeah. The dimensions of the socket and dimensions of the end stop are special for each type of brand, Liebherr, Daymak, Manitowoc, Faun. So it is done mostly on non-rotating ropes for easy reeving or multiple reeving on mobile cranes. Yeah, and you can use it also if you have damages on non-rotating ropes for shortening your wire rope, so that you don't need to buy a whole new rope with an end fitting. Efficiency is into the norm, must be 90% or more, but we can guarantee you that it will be mostly 100%. So they fit into certain sockets, depending on the brand of crane you're gonna put it on, yeah? And saying typically brand specialized things can look like this. You can see there are a lot of different end fittings and stops to put on ropes, each with his specific dimensions, length, width. So be careful that you use the right end stop to be fitted on your rope, and that this end stop will fit into a specific socket from all these different brands of crane makers. Yeah. Okay, another one still used is the hand splice. I mean, splicing strands into the core by hand using the right procedure. Where is it still done? Well, it is done where a ferrule is not used or wished because it's going to be in the way, that ferrule. And initially it was used to have hand splice where there are very high temperatures. Because, okay, don't you have the ferrule? You don't have the swaged ferrule, which is limited in temperature. So there, all the strands are spliced into the core, into the rope, and temperatures can be used till, let's say, the temperatures from your wires or your rope. It is, of course, expensive because it is hand splicing. It costs a lot of time and expertise, and the efficiency there is about 80%. So due to splicing with hand splice into the core, you're going to lose 20% of the minimum breaking load. Yeah. Okay, some people still use wire rope clips. Yeah, as you can see here, wire rope clips can be used, but be careful. Saddle always on the working part. Yeah, you see 3 of these wire clips. They all are mounted in the right way. Yeah? So use it like this. You see the depth part will take the upper side of your clip. Efficiency is about 60 to 70%. It depends also on the type of rope, but be careful. Efficiency 60 to 70% if you use the right number of clips. So each diameter of your rope, yeah, has a certain number of clips you're going to put on the rope. So for instance, if it's 8 millimeter, you're going to use 2 clips. I say if it's 12 or 14 millimeter rope, you're going to use 6 clips and so on. So the higher the diameter, the more clips you have to put on your rope. You see the distance between the different wire rope clips are 5 times the diameter of the rope. Huh? Yeah. Then if you have put the wire rope clips on your rope, you use a torque wrench to get the right tension on your wire rope clips. So you're going to use a torque wrench just to have the right numbers to put it on. And then, very important, after sometimes you need to check that torque again because the rope will get thinner in diameter due to put the load on it. So you need to check again. If you do that, all these things will give you 60 to 70%. Now, let's be honest, nobody is doing this properly, and that's why I would propose it not to use it for permanent hoisting applications. So don't use wire rope clips in situations where you have a hoisting application. Yeah? I have to tell you, check in your country if it's still, let's say, normal to use these things. I can tell you that in Belgium it is forbidden. It is forbidden to use wire rope clips for permanent hoisting applications. Yeah. So only for emergency things you can use it to hold up a rope which has, let's say, a problem, or for temporarily for cases like, for instance, reeving. Then you could put some clips on it just to pull your rope into your installation. So please, I have to mention again, not for permanent hoisting applications. Another termination, very common and used on overhead cranes, is a wedge socket. This is for quick mounting rope, let's say, easy, quickly, and if you have to replace the rope, it's much easier to do it. So it is a house with a wedge. Be careful that house and wedge came from the same brand, very important. There are different designs for different constructions of the rope. So some have wedges which are, let's say, bigger or even more adapted to the type of rope. And also be careful to do a clip onto the tail to block the wedge so that the rope can't go loose if you have a shock or something. Efficiency is certainly lower than 80%, yeah. So it all depends, let's say, on the type of rope, non-rotating rope or high-performance ropes. So efficiency, you're going to lose certainly about 20%. And for some high-performance rotating ropes, there have been a development by Crosby for a special wedge sockets like you see there, where you can have certainty that your non-rotating rope will gain about 80% efficiency. Yeah. Yeah, other things you can put on your rope is a pulling eye. Yeah, there's a welded chain link, let's say, at the end of the wire. This is for pulling your rope into your installation, or for reeving, or for fixing a rope easily on your drum, on your hoisting drum. You also can use for mounting ropes or dismounting ropes, a Chinese finger, cable sock also, that's a woven cable grip. You put it on, let's say, the used rope, or you put it on the new rope, so you can pull it into your installation. Efficiency, well, that depends. It's about 10 to 30%. You don't need much more than this. It's just for taking the rope and pulling it into the installation. Okay, and now something for uncoiling and cutting steel wire rope. I show you the only right thing to do. If the pictures will start, just a minute. Yeah. Yeah, that's technique, guys. It's much easier doing rope than, okay.
Oh, hold on.
No, wait a minute.
There it goes.
Yeah, okay. So let's talk about two things, how you can treat your rope properly. This is not the way you treat a rope. Everybody who's familiar to rope will know that this will get you into big troubles. The rope will be destroyed, so kinks. You use your rope every time. If you're gonna lay it down or you're pulling it in, you put it on the ground like this, or be certain it's gonna be on a reel or on a coil, which will turn. And then for cutting rope, it is certain if you cut a rope like this, and certainly the high performance ropes, yeah, it's gonna split and it's gonna be terrible. Your rope will be damaged. You're not gonna correct it. So what you need to do is you do seizing on a 6 and 8 strand rope. Yeah, you do 2 times seizing on a special rope or a non-rotating rope. You do it 4 times. Yeah, and then you cut it immediately through in one seizing and in one cutting through, and if possible, if it is a non-rotating rope or a high-performance rope, you can fuse it. You can fuse the ends so that the rope won't open up again. So very important. Don't pull your rope. You coil it or uncoil it, and be careful when you cut the rope. You have to do the right seizing 2 times or 4 times, depending on the quality of your rope. And if you have questions about this, well, we can show you more. Just call us and we will inform you how to do it. Okay, that's it, I think, for my part. Let's wrap up. I've talked about all different kind of standard procedures for end terminations. I know there are some others for specific applications, but let's see what we can have already for some questions who popped up. I don't know, Michelle is gonna look, but just to tell you that there is another webinar coming up, I think the beginning of next year. Then we're gonna talk about rigging arrangements, sheaves, drums, and blocks. So I will invite you today already to join next time. Thank you for your attention so far.
Thanks so much, Ellen. We have some questions in the chats. First of all, after this webinar, I think it will be end of this week, you'll receive the recording of this webinar, the slides, and also the Q&A, all in one email. So then you can see it again. Okay, I have a couple of questions. First of all, how do you decide the length of the brush?
Yeah, that depends on the procedure. So you have the diameter of the rope, and then you have to calculate it. So this is done in the procedure. It's depending on if it's 6-stranded or 8-stranded, or that's depend on what is written in the procedure. So you mean the length of the, yeah, if you open it up, you're going to lose some length too, because you have to make a broom. Yeah, so that it is written into the procedure.
All right, thanks. We got a question from Jesper Helman from NOV. How is a steel wire grommet manufactured?
Yeah, but this is, let's say, one of the different kinds of grommet making things. It's not easy to explain this, but in general, what you use is you use one rope, yeah, and you put it into an endless loop, yeah, and then 6 times, yeah, the same rope is woven around the core, let's say. It's not easy to explain this, but yeah, this can be treated in the next seminar. Okay. But it is done by hand, or some of these rope makers have a special machine for it. But it is generally so an endless rope, which is 6 times woven around its own core. Yeah, and then you have a grommet. Yeah, sometimes you also have cable-led slings, and this is, let's say, also a rope made out of ropes, not of strands. The strands are ropes. Yeah, and then they put some terminations on it, eyes to be swaged, or timbals to be swaged, or sometimes they're going to hand splice it also. But this is a completely other topic, let's say. Can't explain it just like this. I need to prepare some slides for it, and then you can see how these things are made. Yeah,
great. We'll explain a little bit in Q&A, but also in the next coming up webinar.
Yeah, okay.
Okay, regarding socketing with resin, you mentioned an expiration date. Is it for the resin before pouring, or also for using the socket?
No, not for the socket. It's just for mixing up your resin. This resin is made out of a fluid and some powder. Yeah, and the fluid and the powder, they have an expiration date. So it's just like medication. You don't use it after a certain date. Yeah, and normally it's I think 1.5 years or 2 years. Yeah, for the resin also, if you mix your 2 components, you have to be sure that your mix is done at 13 degrees Celsius. Yeah, because if it is lower than 13 degrees Celsius, in the case of wire lock, then the hardening of your resin will last much longer. So it takes then, let's say, hours and hours to get stiff, to have your cone formed. So then you can add some little powder, also what's it called, power kits to add. So this will fasten the hardening of your resin. Yeah, and it's called booster socks, I think. So you have to use 1 or more of these booster packages into your resin to harden it much quickly. So if you are pouring your resin into your sockets in your workshop, there normally won't be a problem. But if you do it on the job, next to the crane or something, then you have to be careful that it is done at minimum 13 degrees Celsius. Otherwise, you need to do extra booster packets into your resin. Yeah. Okay.
Long answer, but I think it's fair enough.
Yeah, but it's important.
Yeah, it is. It is. Is there a table available to know the number of clips? Yeah,
depending on the type of clips, because there are certain types of clips. You have DIN 1142. You have clips DIN 741. you have this high performance clips from Greenpin, from Crosby. You look it up into the catalog, or you can use our website to see how many clips you need to use. But again, use it only in emergencies, or don't use it for applications on permanent hoisting ropes. Yeah.
Okay, and another question about clips. Where can I find the amount of pressure I can apply to a certain cable?
Well, normally if you buy the clips at Certex or Mannens, or you're gonna have an application form or how to do it, and there the moment you're gonna need to put on the clips, are written into a table, or also on your using guide, which is normally with the clips. Yeah. And be careful that after the time you do the exercise again. Yeah, because normally rope which are loaded are gonna diminish in diameter, and then you need to do the fitting of your clips with the wrench again. Yeah, so that's why, sorry, but that's why people can't use it anymore in Belgium, not for application. There were some bad accidents, and then okay, the third-party inspectors, they're forbidden to use these clips for hoisting applications. Yeah. So use other end terminations on overhead cranes or on other applications. Use other end terminations. Do it not with these clips. Yeah. Okay.
All right. Let's pick a couple of more. There are more questions coming in, but regarding efficiency, code EN13411 5 states 80% and Crosby 80-90%. You mentioned 60 to 70%.
Yeah.
Can you tell the reason why?
It is prescripted that it should be 90%, but we have the experience that you're never going to get 90%. I wrote 80%, yeah, into the seminar, because this is the real percentage, the maximum percentage you're going to get. There are some manufacturers who did tests on this, and they end up with the maximum of 80%. Even with non-rotating ropes, yeah, 80% is the maximum you're gonna attend to. And if somebody is saying that it's more than 80%, then he has to prove it. Yeah. So we're speaking about this wedge socket, I think. So really, with certain brands like Crosby or other makers of wedge socket, be careful. It all depends on the wedge you're going to use, the diameter of the wedge, the type of socket. Be sure that it is safe, that is well mounted, that you always have a clip to ensure the security that the wedge and the rope can't slip away, and take care that you're only gonna have 80%, not more than 80% of your minimum braking load. Yeah.
Okay. Mikael Raven, what is the efficiency of a swagless terminal?
A what?
Swageless, sorry.
A swageless terminal.
What is the efficiency of a swageless terminal?
I don't understand the swageless terminal. What is a swageless terminal?
I don't know. Perhaps Mikael can put in an extra chat. Otherwise, let's go to the next question.
Perhaps he means also a swageless. Perhaps he also means a wedge socket with a wedge. Something.
Yeah, it's not in the question. So,
okay.
But
sorry.
No worries. Depending on the diameter of the rope, how much pressure can it withstand before being damaged, and on what surface at the torque on wire grips is only specified for the thread? Long question.
That's a big one. That's a big question. Can you repeat it?
All right, let's put it in into two parts. Depending on the diameter of the rope, how much pressure can it withstand before being damaged?
Yeah, well, I think the question is, are we sure that we don't damage the rope with a ferrule pressed on it or with swaged on it, like in the procedure of the Flemish eye? You're gonna not damage the rope itself if you use the right number, let's say, of ferrule, and if you use the proper die for it. Yeah, all this is written into procedures. Every die and every ferrule has his typically press. Yeah? You have to apply, I don't know how many tons on your dies. So this is all prescripted. Huh? Normally you have to be sure that you use the right dies and that the two parts of the dies are closed into your press. But to tell you how many tons and so on, this is typically for the type of press, and it is prescribed for every die and for every press. So it depends on which type of press you have. Yeah. Okay.
Two more questions to go. About your experience, which do you think would be the best or more common socket for cranes?
Sockets for cranes. If you mean mobile cranes, yeah. Then things are getting a lot easier due to 15 or 10 years ago with this end fittings easily for reeving up to multiple reeving systems into blocks. The problem was that there was an end stop which was fitted on the new rope, and if your rope got damaged, you have to replace the whole rope. Huh? And now we have this, let's say, easy socketing on end stops. So you can cut your rope where it is damaged, and then just by pouring the end stop on it, yeah, then you can use your rope again. Yeah, the fitting itself has to be adjusted to. I mean, you have to use the right fitting for the right socket, which is on your rope, and you don't need to buy a whole new rope. Yeah, so it is very common, but of course you have to be certain that the end fitting, the end stop, is the right one for your socket, which is on your crane. That's it for non-rotating. In some applications, these kind of fittings also can be used on 6 or 8 strand ropes. And then normally the fitting will be so constructed that you can't turn the fitting into the socket, so that the socket and the end fitting are blocked together so that the rope cannot rotate into this socket.
Great. Are there any situations or applications where only white metal can be used and resin is not suitable?
What we have seen is for nuclear plants, they don't know what the effect would be on resin poured into sockets after, I don't know, 20 or 30 years. Due to radiation which gets into the resin. So therefore it is not used in nuclear power plants. And there socketing is normally done with liquid metal. I think that's the only application where I know from which it is not forbidden, let's say, but they don't have experience on it because this kind of resin thing is only, let's say, on the market for the last 20 or 30 years. So they don't do it or they don't advise it in nuclear plants. But otherwise, these metal liquid to pour in has the advantage that for emptying the socket again, you just apply the right temperature, and for resin to compound raising, you have to press it out. So you need to have equipment to press it out. So this is an advantage for the liquid pouring on, liquid metal pouring on. Disadvantage, as I told you in the explication, you have this temperature, which will deteriorate your wires anyhow, because these wires will be heated up till 340 degrees, and also your socket will deteriorate if you use your socket several times. Be careful that you don't get higher than 350 degrees, 300. You have to be careful with your temperature, that you don't overheat it, because otherwise you're going to deteriorate your material of the socket. That's it for socketing with liquid metal.
Okay, then we're done with all the questions. Thank you, Michael, for sending over the link, what you meant with sweatlets, but due to timing, we will respond to you directly due to one of our local companies or by Ellen or in the Q&A. So this ends up this webinar. Would like to thank you again for participating in this webinar. During the week, I think the end of the week or Monday, you'll receive an email with all the documentation, recording, presentation slides, and the Q&A. And if you have any questions, please go to your local company or send us an email. And I hope you had a good time at this webinar. Thanks again, Alain, and see you soon, beginning of next year.
Thanks, everybody.
All right. Bye-bye.
Bye-bye.
Bye-bye.